Today we are going to continue our sequence and series, and we're going to talk about some summation, and we're going to start talking about arithmetic series. So you guys already know about arithmetic and geometric sequences along with recursive sequences. So in the do now, and you may just want to pause me for a minute and try to answer the questions and then go back. But I'm going to continue with showing that in your do now, they're talking about an arithmetic sequence. But if you notice, it's defined like this. A sub 1 is 3, and a sub n equals a sub n minus 1 plus 2. That's a recursive sequence. They're pretty much telling you the first term is 3, and to get to your next term, take the previous term and add 2. Okay, so this is pretty much known as an arithmetic series. And if you notice, it's commonly known by these two words, rainbow addition, where if you notice, the different terms are paired off, okay? This series is based on the first 8 terms of your sequence that we said before, recursively stated. And the first thing they want to know is, what is each pair equal? The sum of each pair, what does it equal? So if you notice 3 and 17, 5 and 15, 7 and 13, 9 and 11, every pair adds up to 20. Okay? Next question. Why does it make sense that this sum is constant? Well, because your sequence is constant. 2 is being added from each pair. I would just say that. I would say 2 is being added from each pair. Okay, so in letter C, they say how many of these pairs are there? Well, that's easy. Well, there's 8 numbers, and if we divide it by 2, we have 4 pairs. Okay, you can add up the pairs. Then it says, using your answer from A and C, find the value of the sum using the multiplicative process. So in other words, A and C, if I have each pair adds up to 20, and I have 4 pairs, it means that I have a sum of 80. So in this next part, they want you to generalize this now by creating a formula. Okay, so they want a formula for this series based on the first term, which is a sub 1. Now be careful, the last term, which is called a sub n, and the number of terms, which is s of n. So I'm going to call this series s of n. Okay, to get the sum of the entire series. Well, what would you have to do? You would have to take n, which would be your number of terms, and you would multiply it by your first term and your last term. Okay, so let's think about that. My number of terms, which was 8, if I multiplied it by my first and my last, 3 and 17, which would be 20, that would be too many. That would be 160. What do I then have to do? Take half of it. Because taking half of it is going to divide it by 2, and that's going to mean instead of 8 of them, there's really only 4 of them because we're going to add them up by pairs. So you could see it like that. Another way you'll see it, or it could be written, is literally just take half of n right away and multiply it by your first term plus your last term. Okay, and if you see on the bottom here, this is just a series. A series is defined by the sum of the terms of a sequence. Okay, and you will start to see a series that looks like that, okay? A series is just your set of elements, which is your sequence, and then the sum of all of those numbers, or specifically, sometimes they want you to start at the first term, end at the 5th term. What's the series? That's the sum of the sequence. Okay, so if you guys scroll down here. Here's a better understanding of what all this notation means. You could see here we're talking about summation notation. It's this capital Greek letter called sigma, okay? And they give you all different pieces. So if you look to the right, this 2 to the I power, that's going to be your expression. Whatever's going to be to the right of the sigma is going to be your expression. Underneath your sigma is going to be, okay, whatever they want I to start. So they're telling you I is starting at 0 and I is going to stop at 3. You're not going to see the letter X. You're going to mostly see letters like I, J, K, and N, just so you guys are aware. So what does this mean? I use that same example to translate for number 1. Okay, so here's what this means. If I am giving you this 2 to the I, so let me explain. 2 to the I literally means I'm going to take that I and I'm going to start at 0. So I'm going to replace the I with 2 to the 0. I'm going to keep going now. Now I'm going to do 2 to the first. I'm going to go again and do 2 to the second. And then I'm going to do 2 to the third. Now I'm going to stop at 2 to the third because they want I to stop at 3. And I started here at 2 to the 0. So let's just think this is very simple. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. And 2 to the third is 8. You could add those all up and you would get 15, okay? So let me show you how you can do this in the calculator, okay? You guys can go into GeoGebra and into your calculator to do this. So watch what I'm going to do. If I go into the calculator and I tap on those 3 dots, mine's there because I recently used it, but you're going to type the word sum, okay? Everybody sees that? And next to the word sum, you are going to put in the expression first. So I'm going to type 2 to the, I'm going to use I. Okay, that's my first term, 2 to the I. Then I'm going to define the variable that I used. So my next thing I'm putting is an I. And then I'm going to use my starting number, which was 0. And then I'm going to hit a comma again, and my ending number, which was 3. And when I hit enter, there is my 15. Okay, so I just want you to write in your calculator. Okay, so when you go to the calculator, you are going to click on the 3 dots, and you're going to find the word sum. Okay, so when you pull that up, it's going to say sum with a parenthesis. The first thing you're going to type in is your expression. So I'm going to call that the expression. It's going to be what's right next to your summation. The next thing you're going to do is define the variable. So you're literally just saying, okay, I'm using the variable I. Then you're going to use your starting number, 0. It's where we start. And your ending number, 3. Close your parentheses, and you should have your answer. Okay? So let me show you another one. Let me use a different color. So be careful with this one. You have your summation. It looks like here we're starting at 1. We're ending at 4. And our expression is 13 minus 3k. But just take note of this right here. There's a half in front of the whole summation. That means you're going to multiply your summation, your sum, by a half. So you could put that right into the calculator right in the beginning. So I'm just going to write it out before I start. In the calculator, I'm going to write a half. It's going to then say sum. My expression, I'm going to do 13 minus 3k. What's the variable I'm using? K. I'm starting at 1. I'm ending at 4. So let's put that into the calculator. Okay, so watch. I'm going to first use my half. And then I'm going to click on my 3 dots. I'm going to recently use my sum. My expression was 13 minus 3, and I'm going to go to my alphabet, K. And I'm then going to put a comma and put a K because I am, no, hold on. Got to do that again. I'm going to click on my 3 dots. I'm putting in my sum. I'm going to do my expression, which is 13 minus 3K. Then I need a comma. Then I need my variable K. I went outside of parentheses before. Then I'm going to do my starting number, which here is 1, comma my ending number, which here is 4. And that should be my answer. The answer here is 11. That is the sum of term 1, 2, 3, and 4 of that expression, 13 minus 3K. Okay, so the only thing I just want you to take note of is when you're using the calculator, just make a little note for yourself. You cannot use an X, okay? Use an I, a K. You should be able to use what you see in the problem, but you're not allowed to use an X. It's a function variable, okay? Because it is a function variable. Okay, so just take note. Okay, so let's try another one. So I'm going to go down to this next one. A little bit different. They're giving you, it says which expression is equivalent to the sum of this sequence. So the first thing I would do is find the sum of this sequence. Take 6, 12, 20, and 30, and if you add those all together, you get 68. So I would say use your calculator to find the sum of each in GeoGebra. Okay, so I'm going to prove it to you. I'm going to go into my calculator, I'm going to clear all of this out, and I'm going to practice putting this in and showing you. I'm going to click on my sum, there's my summation. Now, your expression here is 2 to the n minus 10. So I'm going to do 2 to the n. I'm going to click, get out of the exponent, do minus 10. I'm going to hit my parenthesis, my comma, I should say, and I'm going to define my variable. Here, it's n. Now, I'm going to do a start. Here in the first example, it starts at 4, and it ends at 7, which gives me, that has a sum of 200. So the sum of this series is 200. It's not 68. Can't be that one. So I'm going to go to the next one. Go into your calculator, and I am going to go back to my sum. And the expression here is 2n squared, and it's divided by 3. So that's my expression. I'm going to click on my comma. I'm going to define my variable here, which is n. And this one starts at 3 and ends at 6. So there's your next sum, which is 57.3 repeating. Not what we're looking for. Okay, that one's out. Let's try the next one. I'm going to go back into my calculator, touch on my sum. This one has an expression of 5n minus 4. So I'm going to go to 5n minus 4. I'm going to define my letter variable, which is n. This one starts at the number 2 and ends at the number 5. So there is your sum, which is 54. Still not what we want. We want 68. So let's hope that this last one works. When we go back in and we click on our sum, and this one is defined as n squared plus n. So I'm going to go to my n squared plus n. I'm going to define my letter n, and this one starts at 2 and ends at 5. And there it is. So we're good. 68 is the sum of this sequence. There's your answer. That has the exact same sum as what we started with. Okay, let's take a look at the next one. In the next one, they're talking about an arithmetic sequence, but notice how it's written. It's an arithmetic sequence, but this is recursive, okay? This is definitely a recursive formula. Okay, so what does this recursive formula state? It states that your first term, here's your first term, is -2. And then it states to get to your next term, take the previous and add 5. Okay, so if my first term, okay, so now look what this says. They want S of 5, so they want the sum. This literally means they want to find the sum of the first 5 terms. Okay, now with a recursive, you can't put this into the calculator. You could write for yourself, okay, a sub 1 is -2. I could write a sub 2, a sub 3, a sub 4. I don't need this plus. I guess I'm going to want to add them. And a sub 5. So if I just have to add 5 to the previous term, my second term is 3. Add 5, the third term is 8. Add 5, the fourth term is 13. And add 5, the fifth term is 18. So when you add those up, the sum is 40. Okay? 5 and 8, 13 and 18 is 40. There you go. There's your answer. That's all you needed to do. That wasn't able, I can't put a recursive into your calculator, so that's how you would have to do that one. Okay, let's try. So in this next slide, they are just giving you 2 formulas. Now I want you to take note at both formulas. This formula on the left is your arithmetic sequence, okay? This is on your reference sheet. You don't have to memorize that one. And unfortunately, this one, which is what we derived from your first do now question, okay, that's the sum of a certain term of your sequence. That's your series. S sub n is the sum of whatever number of terms that you're looking for. A sub 1 is your first term. A sub n is the last term. This is unfortunately not on your reference sheet. So you would have to memorize that, okay? So I am giving you both of these here, but you would have to memorize that second one, your series formula. So in this next one, it says, Kirk is setting up a college savings account for his son. He deposits $100 per month. Okay, so that's immediately saying to me, that's probably a sub 1. And it's going to increase by the amount he deposits, $10 a month. Okay, so that's arithmetic. Every month he's depositing $10. Okay, if this is arithmetic, you have a clear common difference of 10. Okay, they want to know how much will be in his account after 10 years. Okay, 10 years. Not months. We're putting in $10 a month. So take your 10 years and multiply it by months. We're talking 120 months. Okay, so let's talk about this. They want how much money will be in the account after 10 years. They want the sum of all your months together. Think about it. It's like, okay, you started 100, and then you would add the next month, it would be 110. And then the next month you would have 120, right? If you're adding 110 every month. But think about this. You're not going to do that 120 times. Your last term would be A of 120, A sub 120, the 120th term. So think about your series. to get the sum of your series, okay, I'm going to show this formula. N times a sub 1 plus a sub n divided by 2. So your n is easy. That's your 120 terms. Your a sub 1, we know that. It's 100. Here's the problem. You know you're going to divide this by 2, but do you have a sub 120? You don't. That's what you need to get. Now, here's the best part. Can you get that? Yes. In an arithmetic sequence, whatever term number you want, you can get. So if I write my arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, and I want the 120th term, I could take my first term plus 120, which is my 120th term, times 10. Okay, if you simplify that, your 120th term is $1,290, which means when I come into my series, I could take 100 plus 1,290, and I could divide that by 2. And when you simplify that, you would have $83,400. Okay, that's how much money you would have in your account after 10 years or 120 months. Okay, hope this was okay for you guys. I'm going to give you a little practice sheet, and we'll talk tomorrow.